Welcome to yet another class. I am Dr. B, and today we are going to take another class on logarithm. Here we are going to relate logarithm. We are going to relate logarithm with what? With equilibrium constant. With equilibrium constant. With equilibrium constant. Okay. We're going to relate logarithm with equilibrium constant. Okay, quite funny, but it is important we do this because there is a lot in chemistry, in solving chemistry problems, that is connected to applying logarithm. Let us take, for example, this kind of a question that we are being given. That we are given an equation AA plus BB to give us CC plus DD. And we are told that K, which is the equilibrium constant, is given to us as A, as the concentration of A. Of course, A minus A, between that this is the reactant, and then B minus B, and C minus, C is to C, that's the product, and D is to D. And we are expected to find K. Let's say, let's say to find the logarithm of K, find logarithm K, as the sum of logarithm. Okay, so you can see how it is. Now we are given this equation A plus B giving us C plus D, and we are told that the equilibrium constant is this for this, and we are expected to find the log of K as the sum of logarithm. How do we apply the laws of logarithm to be able to get the logarithm of an equilibrium constant? Now we're going to see how that is possible. Now, first, remember that the question says we should find the logarithm of the equilibrium constant as the sum of logarithms. So it means that to begin, we are going to introduce the logarithm to both sides of the equation, the left hand side and the right hand side of the equation. So we are going to do what? We are going to begin by what? Introducing. We are going to introduce a log to both the right hand side and the left hand side. That means we are going to have the log of K is equals to the log of what? The log of A to A times B to B, minus B rather, times C to C times D to D. That means we introduce logarithm at both sides, since we are asked to find the logarithm of the equilibrium constant as a sum of logarithm. Now, when we get here, we are going to introduce a common convention, from the logarithm laws, and that is we must note that when we have the log of A times B is the same thing as the log of A plus the log of what? B. That is the common logarithm equation. So we have to introduce this to the right hand side in order to get this kind of a convention. So it means that our equation will now change. We will now have the log of K being equals to what? Being equals to the log of A minus A, plus the log of what? B to minus B, plus the log of C to C, plus the log of D to D. We have been able to introduce the logarithm equation to what? To solve this stage of our problem. So at this point in time, we are going to now do what? We are now going to introduce another law of logarithm in order to solve it. Now, to introduce that law of logarithm, it's important for us to note this. It's important for us to note that another law of logarithm lets us to understand that where we have the log of x raised to power a base b, that it can be written as what? A to the log of what? Xb. That means we can return this superscript to the back of the log. Now, if that is true, we can effect this to what? To the right hand side of our equation. That means we can possibly now have the log of k is equals to what? Equals to minus a to the log of what? A. Okay? Minus, which is this? Minus b to the log of b plus c to the log of c plus d to the log of d. At this juncture, we have been able to establish the log of the equilibrium constant as what? As the function of the logarithms of the various concentrations of the reactant. Remember what the question said? The question said we should do what? Find the logarithm of the equilibrium constant as the sum of logarithms. So here this is the logarithm of equilibrium constant as what? The sum of what? The logarithms. Now you can see how the role of what? The role of logarithm in solving chemistry problems. Our previous class we saw how we use logarithm mathematics in solving a problem in pH. And now we also use logarithm in solving a problem in what? Equilibrium constant. And this can go on and on and on. All we need to know is that we must understand the base of mathematics to appreciate chemistry. Don't forget to like and share. Don't forget to subscribe my YouTube channel. Make your comments, observations, all will be attended to. Don't forget also to follow my Facebook page and also to like and share. Until next time, it is bye for now.